US Physics Olympiad, year 2016, F equal MA. First round. For this round, there were 25 problems for 75 minutes. All solutions for these problems you can find in the reference below this video in the description. Problem 1. A car drives counterclockwise around a flat circular curve at constant speed, so that the left front wheel faces out a circular path of radius r equal 9.6 meters. If the width of the car is 1.74 meters, what is the ratio of the angular velocity about its axle of the left front wheel to that of the right front wheel of the car as it moves through the curve? Assume the wheels roll without slipping. Solution. Suppose that car is moving with a constant angular speed, big omega. In that case, speed of left wheel and right wheel will be omega r for left wheel and omega multiplied by r plus d, where d is width of this car. And now we can write what is the angular speed for both wheels. If small r is a radius of wheel, we have this relation for omega for left wheel and omega for right wheel. Now we can just divide omega L over omega R. That will be R over R plus D, which is 0.847. That's answer E. Problem number 2. A 3 centimeters thick layer of oil with density ρ0 equal 800 kg per cubic meter is floating above water that has density ρw equal 1000 kg per cubic meter. A solid cylinder is floating so that 1/3 is in the water, 1/3 is in the oil, and 1/3 is in the air. Additional oil is added until the cylinder is floating only in oil. What fraction of the cylinder is in the oil? Solution. First, we can write the equation for the floating cylinder. So we have mass of cylinder, which is volume of cylinder multiplied by rho of cylinder. That's equal 1/3 volume of cylinder submerged under water multiplied by rho water plus 1/3 volume submerged in oil multiplied by rho oil. And from here we can find that rho cylinder equal 1/3 rho water plus rho oil, which is equal 600 kilograms per cubic meter. And after that we can write equation for floating cylinder. That will be volume of cylinder multiplied by rho cylinder equal volume of submerged part of cylinder multiplied by rho oil. Now we have V submerged over total V equal rho of cylinder over rho of oil, which is 3/4. That's answer B. Problem number 3. An introductory physics student, elated by a first semester grade, celebrates by dropping a textbook from a balcony into a deep layer of soft snow which is 3 meters below. Upon hitting the snow, the book sinks further 1 meter into it before coming to a stop. The mass of the book is 5 kilograms. Assuming a constant retarding force, what is the force from the snow on the book? Solution. Here we can use a work energy theorem. It means that total potential energy of book is heated by force from snow, which is give us equation mg multiplied by height 3 meters plus distance 1 meter equal force multiplied by distance 1 meter. From here we can find that force equal 200 newtons, which is answer E. Problem number 4. Small bit slides from rest along a wire that is shaped like a vertical uniform helix spring. Which graph below shows the magnitude of the acceleration A as a function of time? Solution. Tangential acceleration equal g multiplied by sine theta, where theta is the angle of inclination for this helix, and also moving by circle, and it has a centripetal acceleration which equal to v square over r, which is a tangential square over r multiplied by t square, and finally total acceleration equal this square root, which is this one. And if we look for graphs, the best way is graph D, which is equal to some kind of constant for 0 time, and going like parabola as asymptotic. So that's the only case D. Задача номер 4. Маленькая бусинка скользит из состояния покоя по проволоке, имеющей форму вертикальной однородной спирали пружины. На каком из приведенных ниже графиков показана зависимость величины ускорения А от времени? Поскольку бусинка двигается по спирали, то она имеет тангенциальную составляющую ускорения АТ равно G на синус θ, где θ угол наклона спирали, а также центростремительное ускорение v квадрат делить на r, где r это радиус спирали, или тангенциальное ускорение в квадрате, деленное радиус, умножить на время в квадрате. Отсюда полное ускорение можно вычислить по следующей формуле, которая ближе всего соответствует графику D, то есть равняется некой константе в нуле и дальше ведет себя как парабола.